In the previous section, a simple distinction was made between quantitative and categorical variables. However, there is a more precise method of categorizing variables. It is called scale of measurement. The scales of measurement become increasingly precise with each level, while retaining the characteristics of the level below it. For instance, ordinal data builds on the characteristics of nominal data, and therefore it is more precise than it. Now we are going to take a closer look at the characteristics of these four levels of measurement. The first level of measurement is nominal. It is the least precise measure of data, as it only indicates differences. Nominal level data uses discrete categories to describe qualitative differences. An example of a nominal variable is types of pets. For instance, types of pets could include birds, fish, cats, and dogs. None of these categories, in this case types of pets, is implicitly better than the other. Rather, the categories reflect the different types of pets. Some other examples of nominal variables include gender, eye color, type of house, and type of resident. The categories for each of these nominal variables reflect qualitative differences. Now let's take a closer look at ordinal variables. The second level of measurement is ordinal. Ordinal level data is more precise than nominal data, as the differences can now be ranked ordered. However, it does not indicate that the differences between two numbers are fixed or equal. An example of an ordinal variable is the order of finishes in a race. For instance, we can say that Tanisha finished first and Alexis finished second. However, we do not know the degree of difference. It could be that Tanisha won by 2 seconds or 20 minutes. Other examples of ordinal variables include education level and some survey question responses. The categories for each of these ordinal variables show order, but not the magnitude of difference between two adjacent points. The third level of measurement is interval. It builds upon the characteristics of ordinal data through the addition of meaningful differences between two numbers. That is, the distance between pairs of consecutive numbers is assumed to be equal. However, interval variables do not have a meaningful zero point. Thus, a zero does not mean the absence of an attribute, but rather is a particular, but arbitrary, point on the scale. For instance, when temperature is measured in Celsius, the 1 degree difference, say between 35 degrees and 36 degrees, is assumed to be the same as 1 degree difference between 25 degrees and 26 degrees. However, 0 degrees in Celsius does not mean the absence of heat, since there are below freezing temperatures, such as 20 below. The same characteristics also hold true for temperatures measured in Fahrenheit. Some other examples of interval variables include IQ scores and SAT scores. For each of these interval variables, the distance between pairs of consecutive numbers is assumed to be equal, but they do not have a meaningful zero point. The fourth level and final level of measurement is ratio. It has all the characteristics of interval data plus a meaningful zero point. A good example of ratio level data is age. For instance, we know that someone who is 40 years old is twice as old as someone who is 20 years old. There is a meaningful zero point. That is, it is possible to have the absence of age. Some other examples of ratio variables include height, weight, cost of a car in dollars. For each of these ratio variables, the distance between pairs of consecutive numbers is assumed to be equal, and there is a meaningful zero point. It is also important to note that more precise data can always be scaled down to less precise data. For instance, a ratio level variable like age can be scaled into an ordinal variable of age groups, which could include toddler, adolescent, young adult, and middle-aged. Less precise data, however, cannot be made into more precise data. That is, an ordinal level variable, like age groups, cannot be changed into a ratio level variable, such as age in years. So, why is it important to understand scale of measurement? Statistical methods are ways of summarizing, analyzing, and interpreting data, and are designed for specific types of data. Researchers need to know the level of measurement of their data when selecting a statistical method, since using an incorrect method for analyzing data can affect the reliability and accuracy of the results. Be sure to keep these levels of measurement in mind whenever you are planning to analyze data.